Okay, hello everyone, welcome back to PMAT0028. So this video may be one of the last video of the course because it look like that we covering section 15.4 and 15.5, and this section is the last section of this course. So I try to split up into two videos. On the first video I'll cover section 15.4. In 15.4, we will be talking about how to multiply and divide radical expression. Last time in class, we talked about how to simplify radical expression, how to adding and subtracting radical expression. I also introduced the radical property. Okay, and for multiplying and dividing radical, we also use those property again, but it will be in a it's in a different way. Okay, so let's get started. Section 15.4. Okay, 15.4. The last chapter, the last section is 15.5. So I'm gonna put multiplying and dividing radical expression. Okay. All right. There you go. Alright. Okay, so before I do the first part of lecture, before we do multiplying radical expression, let's do a quick recall of that, the one that we already learned in class. So we learned in class how to simplify radical expression, and we learned two important property. We learned that if we have a square root of a times b, then this is equal to square root of a times square root of b, right? And we also learned that if we have square root of the quotient a divided by b, then I can split it up into square root of a over square root of b. Now, what else we learned? We learned that in order to simplify radical expression, especially when we deal with the square root, the second radical, make sure that we have to split it into perfect square. Okay, so that is the hint I gave you in class. So you have to split into perfect square, because we know that if we have square root of something square, then we can throw away the radical and the exponent. Okay, and the exponent, because for example, square root of 2 square is just 2. Okay, so because 2 square is 4, 4 is a perfect square. Okay, so square root of a perfect square you can throw away. Cube root of something raised to the third power, you can throw it away. Fourth root of something raised to the fourth power, you can throw away. So those are very important things we learned in section 15.1, 15.2 and 15.3 for adding and subtracting. Make sure that we simplify and we add the coefficient of each radical with the same denomination. Okay, so in this section we will be using this property again, but instead of going from left to right, okay, this time we will learn how to use this property from right to left. Okay, so mean we going backward. Okay, so let's get started. So I'm gonna put over here first row. I'm gonna put radical multiplication. radical multiplication. Okay. Okay, so if you want to multiply two radical expression, the good things, a good thing about this is that you don't have you don't have it to have the same denomination. You don't have to simplify it first. So you're gonna apply it. So what if you have two radical like this, and you can combine it as one radical? You can combine it as one radical. Okay, even if we go from right to left with this property. Okay, for example, I'm gonna give you something very simple. For example, I have a square root of 3 multiply square root of 2. Then I can write it as square root of 3 times 2 under one radical sign. Then it gives you square root of 6. Okay, so it's the first example. Very simple. Okay, very simple. You can multiply like that. Okay, or I can have something like this. I can have something with variables, because you see that the radical I have here, there's no variable, just number. I can have something like this. What if I have a square root of 5x, you multiply by square root of 5x also. Okay, or I can multiply. How about multiply by square root of 5x squared? Okay, then I can go from right to left. So I can write it as one radical. So I can just go ahead write it as one radical. I'm not rushing. Okay, I'm just go ahead write it as one radical. If I'm rushing, I can get the answer really fast, you know. But I mean, I treat you as if that you never know this before. So I can write this as one radical, then I multiply them together. Okay, I multiply them together. So 5 times 5 is 25, right? Okay, x times x is x cubed. Okay, but the thing is this, we need to simplify it. We never want to leave this. Okay, we never want to leave this. So I'm going to simplify it. Okay, I'm going to simplify square root of 25. So the square root, this one I can split it up into square root of 25 and square root of x to the third. Right, and square root of 25 is 5, right, because 25 is a perfect square. Square root of x to the third is nothing but square root of x squared times x, right? And I keep splitting it up, so the square root of x squared times square root of x, and square root of x squared is x. Okay, of course, given x must be greater than 0. Okay, so square root of x squared is x, so we'll have 5x, and square root of x you cannot do anything, so I'm going to leave it like this. Okay, so if some of you really good, and you can see right over here, you can jump from here to here, but on the chat you try to show me as many steps as possible. Okay, try to show as much work as possible. So you see that over here they already split up the x and x squared already. If you guys really good, you guys can jump from here to at least this step, then from here to here, and from here to here. But if you're not good, you just need to go through all the little steps like this. So I'm gonna first of all I combine it as one radicals. I go from right to left, then I split up again. So I'm gonna go from left to right, because the step of going from left to right is the step for simplifying. Remember last time we learned in section 15.2 we learned how to simplify it. Okay, So over here I use this property twice. I go first of all I go from right to left, then I go from left to right to simplify it. Okay. All right. Now, what if you have something like this? Now, what if you have a radical and you have a pair of parentheses? Okay. What if something like this? What if I have square root? Okay, what if I have square root of 3x? Okay, I draw the radical really carefully because you see that some of students don't cover the radical the whole thing. Okay, so you have to write carefully. You know, you try to cover. If you want to take square root of 3x, then it means that the radical sign must cover the whole thing. Okay, you multiply by square root of x minus 5 square root of 3. Okay. Okay. So every time you see parentheses, you're gonna distribute, right? So I'm gonna distribute it. So I'm gonna have this multiplied by this minus this multiplied by 5 square root of 3. And I'm going to use the property from right to left, so I can combine it. So we give you 3x squared minus 5. 5 is outside, you cannot do anything, but you can combine this and this, so give you 3x times 3, which is 9x. Okay. Of course, given that in this case x must be greater than 0. Okay, if it's less than 0, we're not dealing with those, because if it's less than 0, then we have to deal with imaginary number. We never learned that. Okay, so over here you're gonna split up. You can split up again. See that? Because we want to simplify it. We don't want to keep this. So we want to simplify it. So we're gonna split it again. Okay, square root of 3 we cannot do anything, and square root of x squared is x, so x square root of 3 minus square root of 9 is 3, so 3 times 5 is 15 square root of x. And now what? Now what we have? We have x square root of 3 minus 15 square root of x, and you see that we cannot do anything else, so we just leave it like this. Okay, we just leave it like this. All right. Or I can give you something like this. Example 4. What if I have two pair of parentheses? So I have a square root of x plus square root of 2. You multiply by square root of x minus square root of 7. So I'm foiling them, right? I start foiling. Okay, start foiling. Let me use let's see, we can use another color. So I'm gonna start folding. So we're gonna fold like this, right? Okay, there you go. We're gonna go like that, and we're gonna go like this, right? There you go. Okay, and what we have? Okay. All right. So what we have will be square root of x times square root of x will be square root of x squared, right? Square root of x times negative square root of 7, so we can combine it under one radical, so square root of 7x, right? Square plus, right? Square root of 2x, you can write it under one radical. You have to be careful, you have to write the radical sign in a way that it covers the whole thing, okay? So square root of 2 times a negative square root is going to give you negative square root of 2 times 7 is 14, okay? And square root of x squared is x. We already learned last time. Negative 7x plus square root of 2x. Let's see, we can do anything. Nope, we cannot do anything here. We can't do anything here. Alright, so we just go ahead and keep it like this. Because it's different denominator, we cannot do anything. and minus square root of 14. 14 is not a perfect square, so you cannot throw away the radical. So this one will be the final answer. Okay, so this final answer. Okay, so over here is final answer. You know, every time I have final answer, I try to draw. I draw a little box and I shade the little box. You know, this is my I don't know. Maybe I'm kind of get used to the higher level math. You know, when you do a lot of proof. You know, in my graduate level back in the day. So I always draw the little square and I shade. Okay, but you don't have to. But I really like it that way. It's good, so that I know that this is the last answer. Alright, so that is how you multiply radical. Alright, so how about doing division? So on the second part, getting radical division. Okay. Again, we're gonna apply the second property. Because the second property is what? Second property say that you can combine it and split it up, or we can go from right to left. So you split it up, then you combine. Okay, you can combine them together. All right. Let's do it. What if I have something like this? Let's do something simple first. Okay, let's do something nice first, easy. The one with number only. So I have square root of 100. Okay, you divide by square root of 25, for example. Then I can combine them. Okay, I can combine it under one radical only. So square root of 100 divided by 25, right? And 100 divided by 25 give you what? 100 divided by give you 4, right? So give you square root of 4, right? And 4 is a perfect square, so square root of 4 give you 2. Okay? So that is so simple. But I just want to show you that you see that with two radicals on the top and the bottom, you can combine it as one radical. Okay. Alright. Now, I'm going to give you an example when we have to deal with variable. What if I have something like this? 12 x to the third. Okay, make sure that I have everything covered. Divide by 3x. Same thing. We're going to just go ahead, write it under one radical. Okay, so 12x to the third divided by 3x. And now you see that 12 divided by 3 gives you 4, right? But we still have a radical because it's still inside of that. So x to the third over x. So we already learned how to simplify exponent expression, remember last time. So x to the third is x to the first. So here 3 minus 1. We subtract the exponent and give you x squared. Of course, in this case, x squared must be every time we have x, so x squared must be greater than 0. Okay. So right now we're gonna split up. You see that? Because right now we have to simplify this. So remember the property when you go from right to left, this is for simplification. But if you go from left to right, it is for simplification. But if you go from right to left, it's for multiplication and division. Okay, so I'm gonna split up. So I'm gonna go from right to left and split up, right? Okay, and over here I will have square root of 4 is 2 and square root of x squared. So this is my answer for example 2. Okay. Alright, let me give you something else. How about something harder? Try to do something harder. A little bit harder. Do we have it enough? Or we just have something like this? I guess that's all. I mean, at this level, you just need to deal with this. Okay, when you go to intermediate algebra or college algebra, you're gonna see this again: radical division and radical multiplication again, simplified radical expression. Everything you see that again, but the problem would be harder. But at this level, that's all you need. Okay, that's all you need. Alright. Alright. So that is for multiply and dividing radical expression. Now I want to show you another way to simplify radical. This method we call rationalization. What is rationalization? Rationalization literal meaning is get rid of a radical under denominator. That's what it means. It means get rid of radical under denominator, because we don't want to a beautiful form of radical expression is the one that doesn't have radical under denominator. Okay, it doesn't have radical. If it has a radical under denominator, then it's not beautiful. It's not in the simplest form yet. Okay, I can give you the example like this. What if I have let me see what color I should use here, because I already use red. Let's use different color for fun. Okay, how about let's use this. Let's see what happens. Okay, what if I have something like this? Oh, it's not really nice color, but that's okay. What if I have something like I have a 2 over radical 7, radical 5. Okay, and I want to rationalize this. The reason I want to rationalize it because you see that this is a fractional form, and in the denominator we have radical. We don't want that. Okay, we don't want it. So we want to get rid of the radical here. We don't want radical. Okay, we don't want it. Okay, so I have to get rid of. So in order to get rid of radical under denominator, what you have to do is, I need to have a drink. What you have to do is you need to multiply the whole thing here. Okay, you need to multiply the whole thing here. I mean the top and the bottom by the bottom. So the bottom is square root of 5. So I need to multiply the top by square root of 5 and the bottom by square root of 5. Why I have to do so? Because when you do that, you see that you can multiply the bottom together, give you square root of 25, right? On the top you can. Okay? Oh, I'm sorry. I dropped something. On the top, you can multiply it. On the top, all you have to do is just rewrite it. Okay. However, at the bottom, look at that. 25 is a perfect square. And square root of a perfect square is give you itself. So give you 5. Because 25 is 5 square, square root of 5 square is 5. So a lot of people know square root of 25 is 5, square root of 100 is 10, square root of 1000 is something like that, blah blah blah. Square root of 81 is 9, maybe, you know, right? Square root of 81, 9, yeah, 9, yeah. So you need to memorize some perfect square number, or you can convert a square. 25 is 5 square, square root of 5 square give you 5. You know, you can go from here to here easily. Okay, you can go from here to here easily. So actually go from here to here, because square root of 25 is 25 is 5 square, so square root of 5 square is 5. So you see that my final answer here, under denominator, there's no more radical. Okay, So on the top, I have radical, that's fine. But the denominator, you shouldn't have radical. Okay, so that is what rationalization means. It means get rid of radical in the denominator. Okay, all right. Let me give you another example. Oh, I don't have more space anymore, but that's okay. I think I have enough. What if I have something like this? Okay, what if I have 1 over 3 square root of 2x? Okay, I have a radical in the denominator, right? So all you have to do is you multiply that by the radical. Over here, I just need to multiply by radical 5 because the whole denominator has only radical 5. But over here, the whole denominator has number 3. But you don't have to multiply by number 3. You just need to multiply the top and the bottom by radical 2x. Okay, so over here, for this problem. Okay, because right now we're dealing with x. So right now we're going to have square root of 2x times 1 is square root of 2x. But 3 times square root of 2x times square root of 2x, I can write it under one radical, right? So 2x times 2x, right? And on the top we have square root of 2x. Over here I can write it as 2x times 2, 2x times 2x is 2 times 2 is 4x squared, right? And now I can simplify the bottom. The top you cannot do anything. You can simplify the bottom. I can split it up like this, right? So you see the property is very important. You have to be very flexible. Sometimes you go from left to right, sometimes you go from right to left. Yeah. But for simplification, you always go from right to left. Okay. So over here, I will have square root of 2x over square root 4 is 2. 2 times 2 times 3 is 6. Square root of x squared is x. This is my final answer. Alright, so that is how you rationalize and radical expression. But what if I have something like this? Let's see. What if I have something harder? Let's jump to the next page. Example 3. What if I have something like this? 2 over 1 plus square root of 3. Okay. What if I have something like this? Okay. Alright. So in order to rationalize this expression, okay, in order to rationalize this expression, you must understand the concept of conjugate. What is conjugate? What is conjugate? Okay. What is conjugate? I don't know. Maybe some of you have heard this before. And maybe not. So, if I have, let me use different color. Okay, in order to do this, we need understanding. Okay, conjugate. What is conjugate? Right. What is conjugate? Oh, I love purple, right? Purple, nice. Okay. So what if I have something like? What if I have algebra expression like I have given a plus b? Okay. Then conjugate of A plus B is A minus B. Okay, so the conjugate of A plus B is A minus B. Okay, okay. All right. However, if given A minus B, then conjugate of A minus B is A plus B. So from this information, I can conclude that A plus B and A minus B is actually a conjugate of each other. They're conjugate of each other. Alright? Alright. Now, after you understand what conjugate is already, I'm going to go back to this problem and solve this problem. Okay, so how are we going to solve this problem? What color will we use? Okay, right here. Oh no, not this one. Oh, right here. All right. It's not nice color at all, though. Alright, so in order to rationalize this, okay, in order to rationalize this, I mean, you need to get rid of radical here. You must multiply, okay? So the strategy is multiply the top and the bottom by conjugate of the bottom. So what is the conjugate of the bottom here? Okay, what is conjugate of the bottom there? Right now we have the bottom is 1 plus square root of 3, right? So the conjugate will be everything except for the sign. So the conjugate of 1 plus square root of 3 is 1 minus square root of 3. Okay, it's 1 minus square root of 3. Then, after we know the conjugate already, okay, I can rationalize this. So let's rewrite the question. So I'm going to multiply the top and the bottom. I will multiply the top and the bottom, okay, by the bottom, by the conjugate of this. So I mean by 1 minus square root of 3. 1 minus square root of 3. Alright. So after I multiply that, I'm going to just go ahead and distribute it. Okay, so I will have I think I'm gonna just go ahead and combine it instead of distribute because it won't have anything. The bottom I distribute, so I'm gonna distribute it. So you see that you can distribute it, or you can see that actually this is a different square. So a plus b times a minus b, so I'll give you a square minus b square, right? Everybody know this formula? Actually, we already learned this formula, right? Everybody learned that. Everybody learns that. This is a plus b, a plus b, a plus b times a minus b is a square minus b square, right? So it's a quick reminder. So from using this, I can get this. A plus will give me a square minus b. B is this, b square root of 3, right? So from here, I can simplify this. So on the top, I keep it because there's no need of distribution. So 1 square is 1. Square root of 3 square. So this is 3 square. I'm sorry. I don't know why I put raised to the third. Okay. So square root of 3 square is 3. Okay. Then from here I got 2 square root of 1 minus square root of 3 over 1 minus 3 is negative 2. Okay, 2 divided by negative 2 is negative. The answer will be negative 1 minus square root of 3. That will be your answer. Then now you can distribute it, or you can leave it like this, but I'm going to go ahead and distribute it. Then it becomes square root of 3 minus 1. This is your final answer. Okay. All right. So that is how you rationalize by using conjugate. I'm going to give you another example. So right here, right now we use old color already. Let me use white color here. Okay. Let me use this one. Example. Right now, example 4. Let's use this color. Example 4. Alright, I want you to rationalize this. I have square root of 5 plus 3 over square root of 5 minus 2. Okay, so I'm going to multiply the top and the bottom by the conjugate of this. So the conjugate of this will be square root of 5 plus 2, right? Square root of 5 minus 2. So I multiply by the conjugate, which square root of 5 plus 2. So the conjugate of the minus is the plus. The conjugate of the plus is the minus. Okay. Then now you can distribute it. So I can distribute it. So it become what? Square root of 5 times square root of 5 is square root of 25 plus 2 square root of 5, right? You for them, right? This to this, this to that, right? This to this, this to this, right? Alright, and this to this, this to this, so 3 square root of 5, 3 plus 3 times 2 plus 6, right? Over, you do the same for the bottom, so square root of 25 plus 2 square root of 5 minus 2 square root of 5, okay, minus 4, or you can apply the difference of square. You can apply the difference of square over here if you want to. Same thing as I did for example 4. You can apply the difference of square here, or you can distribute it. It's up to you. So square root of 25 is 5. I can combine it because it's you see, you already learned how to combine radical. 2 plus 3 you find square root of 5 because it's the same denomination. Minus 6 over 5. This is cancel out, right? Because this is cancel out, so minus 4. So down the top you have negative 1 plus 5 square root of 5. At the bottom I have 1. Then the final answer I will have 5 square root of 5 minus 1. And this is your this is your final answer. Just go ahead and box it. Alright. And here you go. That's it. That is how you rationalize a radical expression. You see that? My answer. Look at my answer here. Very beautiful answer. I mean, there's no more radical under the denominator. Actually, the denominator over here is 1, but if it is 1, you don't need it. There's no radical here anymore. You're allowed to have radical on the top, but you shouldn't have radical on the denominator. That's why we need to learn how to rationalize radical expression. Okay? So I think that's it for this section 15.4. we have one more section left. Okay, stay tuned. I will be back with the last video of the course.